Quadratic functions. So we started to look at quadratic functions in week 1, and these have the form y is equal to ax squared plus bx plus c, where a, b and c are integers and a is not equal to 0. So all parabolas have the same basic shape. Their size and their position will differ. So generally if a is greater than 0, so if our ax is positive, then our parabola will be concave up. Concave up. If our a is less than 0, so we have a negative. So here we've got a positive x squared, here less than 0, a negative x squared value. Here our parabola will be concave down. Graphing quadratic functions. So y is equal to x squared is the simplest of all of our quadratic functions. So similarly to our previous examples, before we graph we need to complete a table of values. So here y is equal to x squared. So 0 squared is 0. 1 squared is 1, 2 squared is 4, 3 squared is 9. Negative 1 squared is 1, negative times a negative is a positive, negative 2 squared is 4, negative 3 squared is 9 here. So if we plot these points, here 0 and 0, here 1 and 1, it disappears a bit in here, but we can see this here, negative 1 and 1, 2 and 4, negative 2 and 4, 3 and 9. Negative 3 and 9 here. So this becomes our curve here, and the more we have more than enough to be able to graph this curve, and we can continue this on here. Another example here is when a is equal to 1. So here we have a is equal to 1, b is equal to negative 2, and c is equal to 2. So if we think of this as our equation, y is equal to ax squared plus bx plus c. So y is equal to 1 times x squared is x squared, negative 2 times x, so minus 2x, plus c plus 2. So here is our equation here. We fill in our values here, so 0 would be 0 minus 0 plus 2. We get the rest of our values here. So here 0, x value, y value of 2. Here 1 and 1. 2 and 2, 3 and 5, and going the other way, negative 1 and 5, negative 2 and 10. So we can plot this curve here, and this will continue up like this. So here we have exercise 4.9.1. We're going to graph the following parabolas using a table of values. So here y is equal to x squared plus 1. 0 squared plus 1 is 1. 1 squared is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. 3 squared is 9 plus 1 is 10. On our negative side, negative 1 squared is 1 plus 1 is 2. Negative 2 squared is 4 plus 1 is 5. Negative 3 squared is 9 plus 1 is 10. So we can plot our points here when our x is equal to 0, our y is equal to 1. When our x is equal to 1, our y is equal to 2. When x is equal to 2, our y is equal to 5 here, and so on. So when x is minus 1, y is equal to 2. When x is minus 2, y is equal to 5, and the 3 and the 10 as well. We draw our curve, and then we write our label y is equal to x squared plus 1. X squared minus 4, we use the same process here to fill in our values. We should have 5, 0, minus 3, minus 4, minus 3, 0, 5 here. So here x is 0, y is minus 4. 1 minus 3, 2, 0, 3, and 5. And the same on the other side, minus 1, minus 3, minus 2, 0, 3 and 5. So we draw our curve in. Y is equal to x squared minus 4. And we can see both of these curves, parabolas, are concave up. So similarly, we're going to plot the points for each of these following parabolas here. So if we go through, we find we have 16, 9, 4, 1, 0, 1, 4. So we might not plot all of this, we might work in 2's on here though. So when x is 2, y is minus 1. When x is 1, y is 0. Sorry, when we look at this, when x is 0, y is positive 1. So ignore that point there. When x is equal to 1, y is 0. When x is equal to 2, here y is equal to 1. When x is equal to 3, y is equal to 4. Here negative 1, here will be also 4. And negative 2 is 9, is outside of our range here or slightly up here. So 9 will be here. And we label it y is equal to x squared minus 2x plus 1. So for our next parabola we have 3 minus 2x minus x squared, and we look here, and so we should have concave down here. We fill in our values, we should have 0, 3, 4, 3, 0, minus 5, minus 12. So x is equal to 0, y is equal to 3. When x is minus 1, here y is equal to 4. X is minus 2, y is 3. X is minus 3 and y is 0. X is 1, y is 0. X is 2, y is minus 5. So we draw our curve in here. So we see concave down, and we label our curve y is equal to 3 minus 2x minus x squared. So we keep going with this here. So here we have minus 8, minus 3, 0, 1, 0, minus 3, minus 8. And we look again here, it should be concave down. So when x is equal to 0, y is equal to 1. X is equal to 1, y is equal to 0. X is equal to 2, y is equal to minus 3. 3 minus 8 is off our scale here. Here x is equal to minus 1, y is equal to 0. X is minus 2, y is 3, and minus 3, 8 again off our scale here. So there is our curve. Y is equal to 1 minus x squared here. So next we look at our basic features of a parabola here. So our basic features. So parabolas can be seen and detected in many fields of engineering. So we have an example here. If a projectile is fired at an angle to the ground, its path will follow a parabolic curve here. The basic features of our parabola are the y-intercept, where we cut through the y-axis, our x-intercept, our axis of symmetry is the axis about which we're symmetrical for our curve, and our maximum or minimum value. Here we have a maximum here. So these features can be identified from quadratic equation and can, if necessary, be used to sketch instead of actually graphing. So we don't need to plot each of our points. We find our important values and we use those to actually sketch our graph here. So here we have y is equal to x squared plus x minus 2. So to get our y-intercept, we set our x is equal to 0. When x is equal to 0, y is equal to 0 squared plus 0 minus 2. So y is equal to minus 2. So here we have our point on our y-axis -2 where we cut through. Our x-intercept occurs when y is equal to 0. So we have y is equal to x squared plus x minus 2 here. So what we can do is we have x plus 2, x minus 1. So here x squared plus 2x minus x becomes plus x minus 2. So here either x plus 2 is equal to 0 or x minus 1 is equal to 0. So x is equal to minus 2, x is equal to 1. So here we have, and it's drawn wrongly on here, we should have minus 2 and we should have 1 here. So our x-intercepts are points where the parabola cuts the x-axis. So we can expect there to be 2 points, but sometimes there may be only 1 point, especially if we have the case where it touches a minimum or a maximum will touch on our actual axis there. And sometimes the parabola doesn't actually cross the x-axis at all. The points where the curve crosses the x-axis and the y is equal to 0 are the roots of the equation. So following example here we have y is equal to x squared plus x minus 3. And they're shown on here. So here we want to plot the graph and observe the x-intercepts here. So if we look at our intercepts here, well, we cut through our y-axis at -3. And when we set x is equal to 0, y is equal to 0 plus 0 minus 3. So yes, that's right here. And now we want to try and find our actual roots of our equation here, or where we cut through. And here we can see, well, these aren't going to be nice numbers, are they? So what we need to do is use our quadratic formula. So y is equal to minus b plus minus square root of b squared minus 4ac divided by 2a. And we just substitute from our equation here. So here a is equal to 1, b is equal to 1, c is equal to minus 3. So minus b becomes minus 1 plus or minus the square root of b squared. 1 squared minus 4 times 1 times minus 3. Here all divided by 2 times 1. So minus 1 plus or minus 1 squared is 1. Minus 4 times 1 is minus 4 times minus 3 becomes plus 12 divided by 2. So here we get minus 1 plus or minus the square root of 13 divided by 2. So our two options are minus 1 plus the square root of 13 on 2 and minus 1 minus square root of 13 on 2. We put these into our calculator and we should end up with these points that we have here. So we have an example here. We want to find the x-intercepts of y is equal to x squared plus x minus 2. So some of these are easier than others to work out. So we have x times x is x squared. We want to get to minus 2. But we see we've got positive x. So we're going to make it positive 2 plus 2 minus here. So we've got these work out to be x squared. Here we have minus 2. Here we've got 2x minus x is equal to x. So here our roots be x plus 2, x minus 1. So x plus 2 is equal to 0 and x minus 1 equal to 0 are our roots. Here x is equal to minus 2, x is equal to 1. So these are the two roots here for our actual x-intercepts here. So when we draw it onto our actual graph and we know our y-intercept, here will be, here y is equal to minus 2. So when we draw here on our axes, minus 2 is where we cut through the y-axis. Here we've got minus 1, minus 2, 1 and 2 here, so 1 there. So we know we're going to cut through like this. We know here, here, and we're trying to make it even. So the next thing we're going to have to do is work out what sort of point we're about here. So where is the middle of this? And for that, we find our axis of symmetry. So it's basically a line of reflection or a mirror through the middle of our graph. Our graph is symmetrical about this line. So the axis has an equation which comes from part of the quadratic formula for solving quadratics, and our axis of symmetry is x is equal to minus b on 2a. So here y is equal to x squared minus 6x plus 5. So we have a is equal to 1, b is equal to minus 6, c is equal to 5. So x here is equal to minus, here minus 6 on 2 times 1. Negative times negative is positive, so we're going to have, well, 6 on 2 is equal to 3. So what we're saying for this, here if we have our point 1, 2, 3, x is equal to 3, we can draw an axis of symmetry here, and our parabola will be symmetric about this point here. So we have an example here. We want to find our x and y intercepts, and we have y is equal to x minus 1, x plus 2 here. So first of all, they've given our formula here ready to go to find our x-intercepts. So here our x-intercepts, we set y is equal to 0. So x minus 1 is equal to 0, or x plus 2 is equal to 0. So we end up with x is equal to 1 and minus 2. For our y-intercept, we're going to have to actually expand. So y is equal to x times x is x squared, plus 2x minus x, plus x minus 1 times 2 minus 2 here. So to find our y-intercept, we're setting x is equal to 0 here. So here y is equal to 0 plus 0 minus 2 equals minus 2. So here we've found our x and our y-intercepts, and now we can also find our axis of symmetry. X is equal to minus b divided by 2a here. So minus 1 divided by 2 times 1 here, so it's going to be about x is equal to minus a half. So here we've got our x is 1, minus 1, minus 2. Our y-intercept here is at minus 2, minus 1, minus 2. So if we mark some of these points on, here we're cutting through, here, here, and here at minus a half is our axis of symmetry. And we know it's positive, we have positive here, so here we're going to be at our lowest point on this axis of symmetry and concave up from here. So now we're going to find here our x and y intercepts and the axis of symmetry as well. So here we set x is equal to 0, so to find our y-intercept, x is equal to 0, 0 plus 4 times 0, y is also equal to 0. To get our x-intercept, so we say, well, here we can take x out of this equation, can't we? X, we have x plus 4 here. So here we're going to set y is equal to 0. So x is equal to 0 and negative 4 here. And our axis of symmetry, we use x is equal to minus b on 2a here. So minus 4 on 2 will be minus 2. For our second equation here, again, we can say, well, we can pull our x out of here. So y is equal to x, 6 minus x here. And we see we have negative. So we know it's going to be concave down shape. Our other graph here, we know is concave up here. So our y-intercept, we set x is equal to 0. Here y is equal to 0. Our x-intercept, so here we set our y to 0, so x is equal to 0. And here x here, and we've got here 6 minus x equals 0, so x is equal to 6. Our axis of symmetry, here x is equal to minus b on 2a. Here minus b is minus 6 divided by 2a, 2 times minus 1. Here minus 6 on minus 2 becomes a positive 3 here. So we have now our intercepts and our axis of symmetry. So another example here, to get our y-intercept, we set y is equal to 0, x is equal to 0, and so our y is equal to 16. So to get our x-intercept, we need to go through here. So we're going to say, well, here y is equal to x minus 8, x minus 2. So here to get our x-intercept, we set y is equal to 0, x is equal to 2 and 8. Our axis of symmetry, x is equal to minus b on 2a, here minus 10 on 2 times 1 is 2, so it's going to be 10 on 2 is equal to 5 here. For our second equation here, we can look at this, and so here, well, what we have, 2 minus x and 2 plus x. So our y-intercept, we set x is equal to 0, y is equal to 4. X-intercept, here, we set our y is equal to 0, so here 2 minus x is 0, x is equal to 2. 2 plus x equals 0, x is equal to minus 2. Our axis of symmetry here, x is equal to minus b, and so here we see we have no b, do we? We have nothing times x, so we think, well, plus 0x, we could look at it like that. So minus 0 divided by 2 times minus 1, but here it's just going to be 0. So our axis of symmetry is when x is equal to 0 or lying here on our y-axis. So some more examples here. So here we've got y is equal to x plus 5, x minus 1. So our y-intercept, here we set x is equal to 0, y is equal to minus 5. Our x-intercept, we set y is equal to 0. So we have x plus 5 equals 0, x minus 1 equals 0 here. X equals minus 5 and 1. Our axis of symmetry, x is equal to minus b on 2a, is minus 4 on 2 times 2, here is minus 2. For our second equation here, y is equal to x minus 3, x minus 3 here. Our y-intercept, when x is 0, y is equal to 9. Our x-intercept, when y is 0, we've got x minus 3 is equal to 0, and x minus 3 is equal to 0. So this is one of our cases where we're going to have one x-intercept, where x is equal to 3. And our axis of symmetry, here x equals minus b on 2a, here minus b, so minus 6 on 2 will be 3. And so what we've got here, where our x is 1, 2, 3, this is our axis of symmetry, and we know this is where we touch our x-axis, and here at 9 is where we cut through our y. So here is our parabola there. The next thing we look at are our maximum and minimum values for our parabola. So here, if our parabola is concave up, so concave up, we have a minimum. If our parabola is concave down, we have a maximum. So a maximum or minimum value, we obtain it by substituting our x value from our axis of symmetry. So our axis of symmetry passes right through this point here. So what we have to do here, we substitute, we've already found what this x value is. So we said x is minus b on 2a. So we find this x here and we substitute into our actual y equation for y. So in week 8 we're going to be actually obtaining maximums and minimums using calculus. The y value obtained is the maximum or minimum value. So we have exercise 4.9.3 here. We want to determine the equations of a and b above, knowing the roots and the intercept of the y-axis here. So if we have a look at this here, our y-intercept here, x is equal to 0, y is equal to minus 2. This is equal to our c. So here c is equal to minus 2. So this one's quite easy here. Now we have our 2 points where we cut through our x-axis. So if we look here, our x-intercepts are minus 1 and 2. So working backwards from how we were working before, here x plus 1 is equal to 0, and here x minus 2 is equal to 0. So we end up with, well, x plus 1, x minus 2 here. So y is equal to x plus 1, x minus 2. We put this together. So here x squared minus 2x plus x becomes minus x minus 2 here. And that's our c minus 2 there that we have already here. So we've found our equation of our line here. And then we can find our equation of our line B here. So we have 2 and minus 1 yet again. So we know, well, this is going to be similar, isn't it? So we know here, well, we're going to have the same sort of thing. Our x-intercept is minus 1 and 2. Our y-intercept here is 2. So our c is going to be 2 here. So what we can do is go through this here. So we know, well, minus 1 and 2, we can use the same sort of thing we did before. But one major thing is here, our curve is concave down. So here it will be negative here. So here, instead of having x minus 1, so x plus 1, x minus 2 is x squared minus x minus 2, it will be negative because we're concave down here. So we end up with y is equal to negative x squared plus x plus 2 here. So for b, we want to find our maximum and minimum values of a and b. So here we have a minimum here. So our axis of symmetry, x is equal to minus b on 2a. Here our b, we have minus 1 on 2 times 1 is 2. So it's going to be here at a half. So here our axis of symmetry is a half. And when x is equal to a half, y is equal to a half squared minus a half minus 2. So y will end up being minus 2 1/4 or minus 2.25. Minus 2 1/4 is equal to minus 2.25. And for our second equation here, our axis of symmetry, here x is equal to minus b on 2a here. So minus 1 on 2 times minus 1. So here again we're going to have a half. Here a half. So here now y is equal to minus a half squared plus a half plus 2. So here 2.5 minus a quarter will be 2.25 or 2.25. If we label this point on here, we'll have our point 0.5, 2.25. Here we'll have our point 0.5 minus 2.25. So now moving on to exercise 4.9.4. We want to find our maximum or minimum value for each of the following. So here, to find here our axis, x is equal to minus b on 2a. Minus 2 on 2 times 1 is 2, so minus 1. When x is minus 1, y will be minus 1 squared plus 2 times minus 1 minus 8. So 1 minus 2 minus 8. Here y is equal to minus 9. So what we have here, it's positive, so here it's going to be concave up, and this will be our minimum. Minimum value will be minus 1 minus 9. For our second equation here, so we find our axis of symmetry here, x is equal to minus b on 2a. Here minus 2 on 2 times 1 is 2, so minus 1. Y is equal to minus, well, so we'll put it in order, 1 plus 2 times minus 1 plus minus 1 squared. 1 minus 2 plus 1 is equal to 0 here. So we know positive, it will be concave up, so we're going to have a minimum at minus 1, 0 here. Continuing on to 4.9.4, we want to find our maximum and minimum for this one here. So we know, first of all, we're going to find our axis of symmetry. X is equal to minus b on 2a. So minus 6 on 2 times minus 1. Minus 6 on minus 2 is equal to 3. Then y is equal to 7 plus 6 times 3 minus 3 squared is equal to 7 plus 18 minus 9 is equal to 16. And here we have negative, so here concave down, so we'll have a maximum at the point 3, 16 here. Continuing on from here, we want to sketch each of the parabolas that we found in question 1 using all the available information to us. So here we're going to go through and we're going to write what we've just found onto our actual thing here. So we had our y-intercept, y is equal to minus 9. Our x-intercept, x at 3 and minus 3. Our axis of symmetry is at x equals 0, and we have a min at 0 minus 9 here. So we're going to say minus 2, minus 4, minus 6, minus 8, minus 9 will just fit here. And here we say so 2 and 4, minus 2, minus 4. So we want to mark some of our points onto here. So we know our axis is about x is equal to 0, which is right on our y-axis here. We cut through our x-axis here at 3 and negative 3. Our minimum here is at 0 and 9, which is also our y-intercept. So here our parabola is like this, and we label it y is equal to x squared minus 9. So for here, number 2, we'll write all of our information that we've found previously here. So we have our x-intercept. Here x is 0 and 4. Our y-intercept, y is equal to 0. Our axis of symmetry is at x is equal to 2, and we had a max at 2, 4 here. So here we look at what we need to label. So here we're going to have x is 0, is 1 point, and x is 4. Cut through our y-axis here at y is 0. We have our axis at x is equal to 2. And we have a maximum at 2 and 4 here. So we draw our curve here. Y is equal to 4x minus x squared. So for our next equation, we put our information that we have already in. So here we have our y-intercept is at y is equal to minus 8. Our x-intercept is at minus 4 and 2. Our axis of symmetry, x is equal to minus 1. And our min is at minus 1, minus 9 here. So here we're going to make, here we can work here with our x-axis 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. And for our y's we need to get to minus 8. So we say minus 2, minus 4, minus 6, minus 8 nearly disappears off here. So now we mark our points. So we cut through our x-axis at minus 4 and 2. Here we cut through our y at minus 8, if we can fit it here. Our axis of symmetry is at x is minus 1 here, and our minimum, just right on the bottom here, we have minus 1, minus 9. So we cut through like this, across, and up here. Y is equal to x squared plus 2x minus 8. Okay, so for our next equation here, we have our y-intercept at y is equal to 1, x-intercept here, x is equal to minus 1. Axis, x is equal to minus 1, and a min, minus 1 and 0 here. So here we're cutting through our y-axis at y is equal to 1. Cutting through our x-axis, x is equal to minus 1. Our minimum is here at minus 1, 0. So here our parabola goes like this here. Y is equal to 1 plus 2x plus x squared. So again, for our next curve, we write the information we've found previously on here. So here we have our y-intercept is at y is equal to 7. Our x-intercepts are at x is minus 1 and 7. Our axis of symmetry, x is equal to 3, and we had a max at 316 here. So what we want to do, we're going to make this go, we will have a maximum at 16, so we're going to say 4, 8, 12, 16, minus 4, minus 8, so on. Here we can do the same, 4, 8, minus 4, minus 8 here. So we mark our points. Our y-intercept is here when x is equal to, so when y is equal to 7. Our x-intercepts are at minus 1, there's a bit close, is there, and at 7 just before here. And we know we have a max at 3 and 16 up here. So this is our maximum. So we go through here, this way, and this way here. And this is our graph here. Y is equal to 7 plus 6x minus x squared here. So now we're going to look at solving simultaneously a linear equation and a quadratic equation by drawing their graphs. So here, the same way as solving two simultaneous linear equations can be found by plotting their graphs and seeing where they intersect. So here we have two equations here. So y is equal to x squared plus 1. So we plot these points here. Our y-intercept here is at 1. And we see it's positive. We don't actually cut through our x-axis here. And so for our linear equation, y is equal to 2x plus 3. So this is our gradient. And here our 3 is where we cut through. Here we cut through the x-axis. And what our gradient of 3 means, if we go across by 1, gradient of 2, we should go up by 2. We go across by 1, up by 2. Across by 1, up by 2. Across by 1, up by 2 here. So that's our gradient there. And we find our points where we actually meet, if we draw it on here, are here where y is equal to 1.54 and x is equal to negative 0.73, and also our point where y is equal to 8.46 and x is equal to 2.73. So we actually label them here. We'd always write our x value first, 2.73, 8.46, and here we have negative 0.73, 1.54. These are our 2 points where we can solve our 2 equations simultaneously. So where they meet these 2 points here. And we can do this mathematically as well. So we can substitute here. We've got y is equal to 2x plus 3 and y is equal to x squared plus 1. So we have y is equal to y, x squared plus 1 is equal to 2x plus 3, and we form a quadratic equation here. We end up with x squared minus 2x minus 2 is equal to 0, and we're going to use our quadratic formula to find our actual value here. So here we end up with x is equal to 2.73 or minus 2.73, and substitute in for y.